Welcome to AP Statistics. I'm Mr. Spencer, and along with Mrs. Lamb, we will be your AP Statistics teachers this year. And we are really excited that you signed up for this course. Now, today, just basically this very first video is introductory, and it's going to be a lot of reading and story time with Mr. Spencer. So I want to warn you that so you might be able to read through your notes a little more rapidly than I go through them. But basically, I'm going to be going through your notes. So first off, disclaimer, for those of you who thought that you were signing up a math class, I feel I make you understand that AP Statistics really isn't a math class. Matter of fact, I consider it a statistics class. Well, that's in the name. And while it uses math like science classes, it's not really a math class. In statistics, like science, we test hypotheses through the design and completion of observational studies and experiments. So, couple things. If you're probably going, if it's not a math class, what is it and why is it important, and does it count for a math credit? First off, it does count for a math credit. Now, the other question, why is it important? Well, statistics is important because I said it is. Now, I know that's like your parents saying, it's because I said so, not something you really wanted to hear, and probably not the most satisfying answer to just about any of you. So how about I pose these questions? How do you think Amazon grew to be so huge and powerful when it only started out as an online bookstore? The answer, their use of statistics and big data. How do you think that Japan became a major manufacturing power known for high quality automobiles when their country and industry was virtually destroyed by World War? The answer is statistics and the use of total quality management. How do you think a baseball team with the lowest salary base became a divisional champion over and over again? The answer is statistics. And for some of you, how do you think a group of MIT nerds got banned from Las Vegas? The answer is statistics. How was an effective HIV screening test created from one that was completely unreliable? The answer is statistics. How are advertisements selected for your computer screen or smartphone? The answer, statistics. How did Target know that a teenage girl that they had never seen and never walked in the store was pregnant long before her father did? Well, the answer is statistics. So let's talk about that Target story for just a moment, all right? And we'll go through it in a little more detail, and I have a link to an article that you may want to read on your own time. So, Target, in the interest of making better use of their advertising budget, they began utilizing statistics to better identify the purchasing patterns of their customers so that they could send advertisements that might be of greater interest to each customer. In other words, based on what a person purchased or looked at, online, Target was sending advertisements and coupons to them for things that Target was predicting that the customer might want to purchase. To that end, a teenage girl was receiving advertisements for baby items. As a result, an angry father walked into a Target outside of Minneapolis demanding to talk to the manager. And demanding to talk to the manager. And he said, my daughter keeps getting this mail from you guys advertising baby stuff. And she's still in high school and you're sending her coupons for baby clothes and cribs. Are you trying to encourage teenagers to get pregnant? Are you trying to encourage my daughter to have a baby? And he was extraordinarily angry. The manager really had no idea what the man was talking about, and just looked at the mailer and said, sure enough, it was addressed to the daughter and contained advertisements for maternity clothing, nursery furniture, etc. The manager apologized and then called a few days later to apologize again, which I thought was pretty good. On the phone, however, the father was somewhat taken back, and he said, I've since had a talk with my daughter, and it turns out that there's been some activities in my house I haven't been completely aware of. She's due with a baby in August. By the way, right below here are some articles that relate to this story and what was going on. So you may want to take a look at them. But basically what was happening is Target was looking at what the daughter saw online and what she was clicking on and the items that she was checking out, and determined that the daughter was either pregnant or going to be so, and started sending advertisements to them, although they had no idea as to the age and of the girl, etc. So big data, that's what statistics is. It's big data. So now let's go back and answer that question that really is, what is statistics? So we have this great definition. Statistics is the study of how to collect, organize, display, describe, and analyze data from a sample in order to make generalizations about a population. Now, isn't that awesome? Now, I'm sure most of you are sitting back and going, great, another definition that my teacher believes explains everything, but in reality, it leaves more questions than answers. And that's what I would have said too if I just read that. So give me a few minutes and I believe I'll be able to break down that definition and give you an overview of the course at this time. So AP Statistics is broken down into 4 main sections. The first section is collecting data. The second section is displaying and describing the data that we collected. So in other words, what does it look like? How would we describe it once we've collected? And some of that stuff you've done before. You've looked at graphs, you've made graphs, you've talked about mean and median. And so some of that is going to be a refresher. Then we analyze the collected data. In other words, we take the probability of getting data like that. So I only looked at a small portion of the population. That small portion is known as a sample. And I'm using that small portion to represent the population. And it's like, what is the chance that I would get data like that? Once I've come up with that probability, I make a decision. And that decision is called an inference, making an inference. So our 4 sections are collecting data, displaying, analyzing, or probability, and then making inferences on that. The first quarter will be devoted to collecting data and displaying and describing data. These 2 sections are generally considered by most students the easiest of the course. And it's imperative that you do achieve really good grades in both of these sections for 2 major reasons. First, the collection of data is foundational to all other sections of the course. And secondly, the second quarter, which is comprised almost entirely of data analysis, in other words, the probabilities section, is for most students the most challenging portion of the class. So yeah, most students say probability is hard, and their second grades tend to be a little lower than that of the first quarter. So it's really important to have those first quarter grades up. Now I'm going to take a moment and go sideline for just a moment. And while collecting data is probably the easiest portion of the class, it's vocabulary. It is actually in real life probably the most difficult to carry out. Okay, easiest section of the class because it's vocabulary, memorization, and writing, but probably in reality, real life, the real world, most difficult to actually be successful. And then we get to our final section. So our first section was collecting data. Second section, displaying and describing data. Third section, probability. And fourth section, making inferences or decisions. And this is really awesome. This is where you get to make decisions based on the data. Should we purchase a new machine? Is the new drug more effective? Is the vaccine effective? Is it safe? Can blank predict blank, and how much, and with how much confidence? I love the inference section and feel it's empowering because it's from that section that I can use all of the collected data to make an informed decision. And it's no longer just a guess, all right? Now, I want to be perfectly clear about the word guess. In statistics, even though I'm making a decision, nothing is certain, all right? Matter of fact, I like to say there's always a chance. So however, with statistics, I'm able to determine what chance that I might be wrong as well. Typically, I will choose to be correct 95% of the time. And I know most of us like 95s for grades, so it makes sense. Let's be right 95% of the time, which means I accept the probability that I'm wrong about 5% of the time. But I'm kind of getting ahead of myself, as these discussions will not occur in detail in the third quarter. As we begin this course, I should warn you, there are a significant number of definitions that must be learned in order to understand what we are trying to accomplish. And it's critical that you learn them in specificity and you're able to write about them clearly and concisely. So how important are the definitions? Well, super important. Put it this way. On your very first test, I don't think you're going to have to do any mathematical calculations. And that's not to say the first test is easy. It's just a recognition that statistics is different from all other math classes that you've taken thus far. It really is a reasoning and application course. And you're going to see real world every day in this class. Incidentally, the first test tends to be challenging for many students. And not because the topics are difficult, but because you are asked to think and reason in a different manner. You know, in previous math classes, you followed an explicit set of directions to find a solution. They said turn left and you turn left. They said turn right if you see this. Do this if you see this. And I'm not saying that list of directions was always easy. But in statistics, you'll be able to not only know and apply the definitions and methods, but be able to relate them to the outside world. And in fact, the more you know about the outside world and other subjects, the more connections you'll be able to make and the more successful you will be in this course. That is how application driven it is. So back to our original decision and why we need statistics. And as we said, it's a study of how to collect and organize, display, describe, analyze the data from a sample in order to make generalizations about a population. But to fully understand what this means, you have to know what a population and a sample are. And I'll briefly touch on sample next week, but population. Population is the entire group of subjects or individuals that are of interest. If I wanted to know the average height of adults in San Antonio, my population would be adults living in San Antonio. Then we have this thing called a parameter. And a parameter, by the way, is kind of nice. The P in population, the P in parameter, the P in population and the P in parameter, they go together. And a parameter is just the numerical measurement of the population. All right. And let's just say that we knew that the average height in San Antonio was 5'6". We don't know that. In fact, parameters or population measurements are rarely known. And because they're rarely known, we often have to take samples. Okay. And we'll talk more about that in a little bit. So one of the ways we gain a population parameter is we take a census, which means that we talk to every individual in the population. And if we were talking about the AP statistics class, I probably could get the average height in AP statistics because I could measure all of my students' height. And that would be reasonable, and that would be conducting a census. And if I did that, my population would be the students in my classroom. The parameter would be their height or their average height. And because I surveyed everyone or talked to everyone and measured them all, that would be a census. That probably wouldn't be reasonable to conduct a census of all the heights of adults in San Antonio. So when we get to large populations, conducting a census is very difficult. But we take a census every 10 years in the United States, and we survey everyone in the United States. So in statistics, a population is the entire group or subject or individuals that is the subject of interest, while a sample is a subset of the population. For right now, that's what you need to know about sample. A sample is a subset of the population. And remember, I said the measurement of a population is a parameter. Both starts with an P. The measurement of a sample is that dreaded word statistic. Okay, and a sample is a subset of the population. For example, we may be interested in the percentage of students in your class that have brown eyes. In that case, our population would be students in the class. And it'd be fairly easy to count and figure out the percentage of brown-eyed students in the class. The percentage of brown-eyed students would be the parameter, because we were checking the eye color of the entire population, the eye color of the entire classroom. And because we checked everyone, we conducted a census. And it was reasonable to do so because we had a small sample. And the great thing about conducting a census is if we know the true population parameter, we don't even really need statistics at all. All right? So we don't need statistical methods. We do not need stats class if we're able to conduct a census. So why not perform it all the time? Well, that answers the question. Let's consider the percentage of students of brown-eyed color scenario. What if my population is not the students in my classroom, but all the students of Reagan? A little more difficult, might be possible, but probably still doable, even though there are absence and tardies and things like that, but we could probably pull it off. However, if we wanted to do San Antonio, it would be really virtually impossible. What if it were the United States or Texas or the world? Then at that point, it does become possible. So why don't we collect data using census? Sometimes it's impossible to conduct a census. Here's another example. If I wanted to know the average size of bass in a particular lake, I really couldn't conduct a census without draining the lake and counting all the bass, in which case the bass are dead and there is no lake, so that really doesn't work. On a more sick side or demented side, I cannot count the number of red blood cells in your body without removing all of the blood cells from your body and sucking your life away, which I plan to do in this class with statistics. Further, a census can be extremely expensive. The 2010 census cost $13 billion, which is approximately $42 a person, which is your tax dollars at work. Now, you would think with that type of money, they'd have done a good job, but let's look back at what we do know from other censuses. In 2000, it's estimated that 6.4 million Americans were missed in the census. In other words, they were never counted. They were never accounted for. However, there was an overcount of 36,000 students. Now, the question is, how in the world did that happen? Well, it just means that some people were counted twice, and it's very easy to do. And you guys very shortly would be the ones who might fall in that category. You go off to college and you get the census count and you fill it out because, hey, I'm an adult, I get to participate. Your parents, on the other hand, are sitting there going, I'm still footing that college bill, so I'm filling it out. Or what happens if your parents are divorced and one parent counts you and the other parent counts you? All right, so it's very easy to overcount. And so we overestimated by 6.4 million people. And we ended up, so we missed 6.4, but we still had an overcount of about 36,000. That's pretty amazing. It's also estimated that in Hidalgo County in Texas, 225,000 persons were not even counted. They were not accounted for. And these could be homeless people, people that are moving, et cetera, or other reasons. Now, so in statistics in this class, we will use samples to make generalizations about the population. So ultimately, we're going to take samples, look at their statistic, and make a generalization about populations. And that is what the course is about. All right, thank you. That'll be the end of this video.